I can determine if a graphed line is proportional. So let's take a look at this. Anytime that you see a line that's been graphed, if you look for two characteristics, if it's a straight line, and if that line is going through the origin, then it's proportional. So here's our y-axis and x-axis. This is the origin where the y and x-axis meet. Let me label that for you. And if that line is straight coming out of the origin, then yes, it's proportional. So let's take a look at this. I'm going to start drawing a few lines on here with A and B. You can pause the video and think about what the answer is. And the question is very simple. What I draw on A and B, is it a proportional relationship? And you've got to look for the straight line, and is it from the origin? If you can't say yes to both of these aspects, it's not proportional. So here we go. Okay, A, is it proportional? Yes, and it's pretty simple. It's through the origin right there, and it's a straight line. This one is through the origin, but it's not a straight line, so the answer would be no. Okay, A, is it proportional? No, just because it's through the origin is not enough. It also has to be a perfectly straight line, and as you can see, it kind of turns and twists right here. B, yes. Okay. Now, A, I meant for this to be a straight line, so if you said no, technically you're right because it's not a straight line. But if this was a straight line, and because it came through the origin, yes, that would be proportional. B, it's not through the origin, so automatically it's not proportional. So hopefully you get the idea of that. Let's take a look at another graph of a proportional line. And this time we've got, our grid on here, and we've got it labeled for our x-axis and y-axis. And that's going to let us be able to do a little bit more. But what I want to do is I want to find something called the rate of change. And sometimes instead of calling it the rate of change, they will call it the constant rate of proportionality. Well, what they're trying to describe here is a movement that's a pattern, and it's very predictable. Any proportional line that's straight through the origin, you can find this pattern. And in this case, the pattern is I went up 2 and over 1. And so we will repeat this pattern and wind up on the line again, up 2 and over 1, up 2 and over 1. And so it lets us be able to predict where the line's going to go to. If I had more of a graph, I could see it's probably going to hit right here. I'd be going up 2 and over 1, and it would hit right about here. And that's very useful data there. Well, to go a little bit further with this idea of rate of change, which is just this pattern that you see of, how the line moves from one point to another point, we want to use a little bit of math, a little bit of algebra with it. And instead of writing out the word rate of change, I'm going to write out ROC, which stands for rate of change. And it uses a formula, y divided by x. Now you have to reach back to at least 6th grade math. You might have learned it in 5th grade. But you'll have to understand that every single point has coordinates. And it's an x value followed by the y value. So we're going to use this spot right here to remind you how to do that if you've forgotten. You trace the point down to the x-axis and see what number it's at. Well, the x value, this point right here is on the x-axis. See the x is at 1. So I put parentheses and I put a 1 there. Why? Because the point's right over 1 on the x-axis. Then we sketch it over to the y-axis, and we see it's at 2 on the y-axis. And so the point is 1, 2. My x value is 1 because it's over the 1 on the x-axis. My y value is 2 because it's at 2 on the y-axis. My equation is y divided by x. And so all I have to do is take the points here and divide it. So my rate of change for this proportional line is 2 divided by 1. And what's 2 divided by 1? 2. Now, what does this 2 mean? Well, it's definitely your rate of change, and so if they ask you the rate of change, there's your answer for that. But what's it mean? It's talking about the rate of change for this line, and it means that this top number would be telling you how many it went up by, 2, and the bottom number would be telling you how many it went over by. And so when you get a rate of change that's not a fraction, you can easily make it a fraction by putting a 1 under it. And that's telling you, hey, up 2 and over 1, up 2 and over 1. So the top number is always for your up or down movement, and the bottom number is for your left or right movement there. So let's go try a different point here. This point is over the x of axis of 3, so 3 is my x value, and my y value is going to be 6. We said, how do you find the rate of change? Well, you take the y value and divide it by the x value, so 6 divided by 3. And we still get the 2. So you can use any point except origin. And what's going to happen is, if you use this, you would say 0 divided by 0, and then you're going to get an error message on your calculator because you can't divide by 0. So all I'm going to say is don't use origin. You can use any point on this line to find the rate of change, just like we did here and what we did here. And you'll get the same answer, just don't use the origin. How do you do it? You take the y value and divide it by the x value. Now, sometimes they're not going to give us a graph like they did here. Other times they're going to say, could you find the rate of change from an XY table? And so what I'm going to do is I'm going to take these values from these points right here, like this one's at 1, 2, and this one's at 2, 4, and this one's at 3, 6. And remember, the first number is always an x, and guess what we're going to put in our x column? 1, 2, 3. And the y that goes with this x is a 2, so there's a 2. The y that goes with that x value of 2 is a 4. And this one is a 6. So if they do not give you a graph, but they just give you an XY table, what they've done is they've taken the coordinates from these points on that line, and they say, hey, what's the rate of change? Well, you know that the rate of change is y divided by x. So take this y, 2, and divide it by the x, 1. What's my rate of change? 2. Y divided by x, 4 divided by 2, 2. And 6 divided by 3, well, still going to be 2. So it doesn't matter which point that you use on this table. If they say, hey, just what is the rate of change, choose one of these points, take the y divided by the x. Here's your answer. Now, do you remember how to tell if a line is proportional or not? This one is yes, because it's through the origin, and it's a straight line. This would be no, because even though it's a straight line, it's not through the origin. Occasionally, you'll get asked about table data, like right here, and they'll say, is it proportional? Well, if we graph these points, we could see, but there's another trick. If you go and find the rate of change all the way down, and if it's the same, we'd say it's proportional. If there's one thing that's different on the rate of change, it's not. Now, you do remember I said don't worry about the origin. So that 0, 0, just skip that if you ever see it in a table, because that means it's right here. And we don't want to do that because 0 divided by 0 is an error, and that doesn't help us. But what I do see here is 4 divided by 2 is 2. 100 divided by 50 is 2. And 12 divided by 6 is 2. So since my rate of change is the same all the way down, I would say yes, it's proportional. Let's go try this one. Negative 1 divided by 3, and I would get this on my calculator. It'd be negative 0.3 repeating. Now, this doesn't mean, hey, this is not proportional. I have to go and see if I get negative 0.3 every single time. If I get negative 0.3 repeating every single time, then yes, it's proportional. If I get something that's not this, well, it's not proportional. What's 2 divided by 4? That'd be 0.5. So what you see here is because I got 0.5 and it's different than the negative zero point 0.3 repeating, they're different rate of changes. So no, it's not proportional. So that's how I would handle that type of question. Now let's go through a recap. Can you tell if a graph is proportional? Well, here's your y-axis and x-axis. If it's through the origin in a straight line, it's proportional. How can you find the rate of change from a graph? Well, we take a point, we find its ordered pair, and we take the y value and divide it by the x value. 6 divided by 3 is 2, so my rate of change is 2. So that's what you do. You just go find one of these points, find the ordered pairs, take the y divided by x. Do not use the origin. Number 3, how can you find the rate of change from a table? Well, it's set up for you to literally take the y and divide it by the x. There's your rate of change. Don't use the 0, 0. Again, that's the origin. You'd get an error message. And then the last question, how can you tell if a table is proportional? Well, that's where essentially you go through and you find the rate of change all the way down. And if it's the same, yes, it's proportional. If it's different, like it was here, then no. And how do we find the rate of change? Y divided by x. So a little bit repetitive. Hopefully it's bored you to tears, but to the point that you can actually do these problems in your sleep. If you have any questions, please let me know.